was the last for satellite and material and so forth. So how can you manage to do that question? Solution. So it's just part P, it's a progress of what you've done. The questions was asking us on the data given, and this will be the force. Okay, so this is force step. Force state. So the force state, what is required is speed of 40 of Jupiter. So the speed of the Jupiter, we say that we have to recall an orbit like this. This is the sun. At the sun, and here we have mass of the sun. This is mass of the Jupiter, and here we have force of attraction, but also we have another force that I used to teach in previous lecture that we call it centripetal force and centrifugal force. Basically, for our case, we're interested in the centripetal force. So the fifth state we say that we call what? Call formula of 40. We call the formula of centripetal force centripetal. Centripetal force. Centripetal force. Simply, this is S. Okay? Okay. So that's about it. So we say that if from circular motion, the centripetal force is the mass of the Jupiter times 30 velocity of the Jupiter square of what? R square. This is the radius of what? So we say that for the case of centripetal, so here we have radius of centripetal square. No, sorry, not radius of the Jupiter. Not a square. It's mv square because centripetal is mv square over r. Right? So if that's the case, you say again that from circular concept, the linear velocity is equal to angular velocity times 30 radius of the Jupiter. However, that this radius of the Jupiter, we use the lowercase. So we should keep on using lowercase. Radius of Jupiter. So then we say that centripetal force is equal to what? Mass of Jupiter, and then what? Angular velocity square of Jupiter, radius of Jupiter, over this is the radius of Jupiter square. of what? Radius of the Jupiter. At this radius of the Jupiter also is squared. Let me clarify this point here. Not squared, I'm sorry. Let me clarify it properly, so you should not get confused with simple issues like this. We said we are recalling the centripetal force. Usually we say that mass times velocity square over r. So in our case, the centripetal force, okay, provided to the Jupiter so it can move constantly in its orbit, is equal to the mass of the Jupiter, velocity square of Jupiter, of the radius of Jupiter. Right? So centripetal force is equal to what? Mass of Jupiter. We have linear velocity, the angular velocity of the Jupiter, radius of Jupiter, but this one is squared. Then of what? Over radius of Jupiter. This is radius. Right? Are we together? But we are looking for the speed. So we should not express this linear velocity in terms of angular velocity. We are looking for the speed. Okay? So because we are looking for the speed, instead of making the speed the subject, is equal to centripetal force, radius of the Jupiter, over mass of 40 of Jupiter. Okay? So, but also he said that the sixth state, he said and they've discussed that the centripetal force is equal to force of attraction. Right? It's equal to the force of 40 of attraction. So he said that velocity of Jupiter is equal to the square root of 40. Centripetal force, which is equal to gravitational force, we found in part 1, times what? Radius of Jupiter, we have it, divided by what? Mass of Jupiter, we know it. So then, say that is, again, the speed of Jupiter is equal to what? Gravitational force, which is 4.2 and 4.7 exponential 23. Radius of the Jupiter is what? 7.8 exponential 11. Divided by this is divided by what? Mass of Jupiter. Mass of Jupiter is equal to what? 1.9. 1.9 exponent. So 10.9. 10.7. So 10.7. So find the velocity of Jupiter. So if you find it clearly without committing any error, it is 1.3 exponent 4 meters per second. 1.3.4 meter per second. 1.3.4 meter per second. So you say therefore the speed of what? Of 3 meter say that the speed of Jupiter, the speed of Jupiter is 1.4 meter per second. Speed of Jupiter is 1.3. Action at 4 meter per second. 1.3 is 4 meter per second. Yeah. So that's the speed of Jupiter around the Sun. So if you eliminate this exponential sign, then this is what? So if you eliminate that, so this is equivalent to 13000, so 13 meter out per second. How many kilometers are there? 13 kilometers. So Jupiter revolves around the Sun at the speed of 13 kilometers in 1 second. Can you imagine? 13 kilometers in 1 second. How about you? How many seconds you can revolve around your house? Complete one period. Not complete one revolution. So we have to proceed with problem solving. Still have only 2 questions, then we end the session. But 1 question should be your homework. This is example 05, if I'm not mistaken. Refer Melcon page 204, question number 7. You can check it. The gravitational force on a mass of 1 kilogram. On a mass of 1 kilogram, the gravitational on a mass of 1 kilogram, this is on the mass of 1 kilogram at the Earth's surface. At the Earth's surface. Here, add this description that this is the concept question. At the Earth, at the Earth's surface. Is 10 Newton. Just that you have any question, please ask in the comment section. The gravitational force, add the word force here, on mass of 1 kilogram at the Earth's surface is 10 Newton. So that is not there. Assuming the Earth is a sphere, this is what is a sphere. Is a sphere. Assuming the Earth is sphere of radius r. Radius r, calculate the gravitational force calculate the gravitational force the gravitational force in a satellite. On the satellite. On a satellite mass satellite of mass 100 kilograms in a circular orbit of radius 2r. of radius 2r. Radius of 2r from the center of the S. From the center of the S. That's the end of the question. Can you try it? The gravitational force on a mass of 1 kilogram at S surface is 10 Newton. The big events, the force of attraction between a body of 1 kilograms and the S surface. Then assuming the S is sphere of the radius r, calculate the gravitational force on the satellite of the mass 100 kilograms in circular orbit of radius 2r from the center of the S. How do you solve it? Okay. Think a minute and then try yourself before. Pause the video. Pause the video, try the question, and then after you've tried, you continue on looking the solutions and check yourself if you understand or you don't understand. Okay, it's a little bit tricky question because just few data. You just have a gravitational force of 10 Newton, 1 kilogram, 100 kilogram, 2 r, that's all. So the first step always, data given, analyze them. Data given. Right? So you have a body of 1 kilogram. So we say that mass of the first body, first object, M1 is equal to 1 kilogram. And then the force of attraction, and in that case, in that body in the S, is 10 Newton. Then calculate the gravitational force on the satellite of mass of that one's, mass of the satellite, and let this mass of S, this is 100 kilogram. What you have to find, force of attraction. So this is force of attraction between the body and S. So force of attraction between satellite and S. That is required. I don't know if you have understood this notation. This is the force of attraction between Sun and the, it's not between the satellite and S. Again, we'll be given at the radius in the circle orbit of that one. So assuming the S is a sphere of radius r, so we have the radius r as the radius of the sphere, but also radius of r as the radius of the sphere. Then we say the circular orbits of the radius of 2r. So radius of the Earth, so we say that radius of satellite is equal to twice radius of the S. Right? So if that's the case now, let's go to the second stage. So here you have two different cases. And you have to know how you can link them in order to find the value that you've been asked to find. So we go for the second step. The second step, we say that consider a body of mass M revolving the sun. Now, S. So it means that if the force of attraction, and in that case, the mass is mass of the S, gravitational constant over radius of the S square. Right? So that's the first case. So if this is the first case, we have nothing to cancel. We'll be given this force of attraction. We'll be given the mass of the body. It is what? Because the gravitational force on a mass of one kilogram. So mass of the body. So it is 1 as mass of the S, gravitational constant, radius of the S squared. So this will make what 10 is equal to mass of the S, gravitational constant of what? Radius of the S. So we go for the third step. The third step, we say that now we have the satellite. So remember that for this case, if you want to sketch, just sketch like this with this, the body M, it's the S. So we say that consider the satellite consider satellite on the S surface. So we consider on the S surface, we don't know its force of attraction. And then the mass of the satellite is 1,000. It's the mass of the S. And then the resulting gravitational constant. The radius of the satellite, for this case, I think the questions is twice R. Right? So we are looking for this force of attraction is equal to 0.5 mass of S, gravitational constant, of what? R squared. Are we together? So this is question 1, this is question 2. What the relationship between question 1 and 2? Mass of the S is common to the mass of the S. Gravitational constant is common to gravitational constant. We are not given. However, that we know the values, but we are not given for this case. Read the question from the beginning to the end. No any universal gravitational constant value has been given or mass of the S. So be careful on that. So we go for the first step. Then I will give you the homework. Get prepared for the homework on gravitation so that you enjoy your time with the homework. The first step, we say that substitute make G mass of the S, the subject. make GMA the subject and the substitute in equation 2. In equation 2. So if you substitute, so if you make the subject, you'll find that the mass of the S, gravitational constant, is equal to 10 radius of the S squared. This is radius squared, excuse me, write it in. So then we want to substitute into the force. You are looking for the gravitational force. So that one is 25 times 10 times r squared over r squared. So r squared and r squared cancel. So what the response? Response is 250 Newton. So the force is 250 Newton. Enjoy the beauty of physics. So therefore, the gravitational force is 250 Newton of the satellite. So I believe that now you are competent in solving problems of gravitation, this concept. So the homework is the nectar question. Homework, and this is homework 4. And also it is example. So this is the questions that's been asked in 2000. So this question can refer advanced certificate secondary education examination or nectar question. Or physics, physics 1 in year 2015. Question number 6, now you can solve it. Roman 1 asking you that state Newton's law of gravitation. Situation law, Newton's law of gravitation. State Newton's law of gravitation. And the question. So state Newton's law of gravitation. Roman 2, use the law stated in that one. Use the law stated in what? In A, Roman 1, derive Kepler's said law. Kepler's said law. Kepler's said law. Then C, then B, Roman 1, briefly explain why Newton's equation or universal gravitation does not of the universal gravitation does not hold for bodies falling near the surface of the earth. Does not hold it for the body bodies falling near the surface of the earth. So Roman 2, it's a little bit, we didn't cover that concept, but it's asking you that show that the total energy of the satellites in circular orbit equals the half of the potential energy. Roman C, what would be the length of the day if the rates of rotation of the earth were such that the acceleration gravity G is equal to 0 at the equator. Calculate the height above the Earth's surface for the satellites in the parting orbit. So I haven't taught you. So this is the homework. So the homework states Newton's law of gravitation. There are some marks. Mostly it might be 1 or 1.5. Then use the law stated in A above, here, above, to derive the Kepler's said law. See the tricks that the agents ask question. Briefly explain why Newton's equation of universal gravitation does not hold it for the bodies falling near to the surface of the earth. Okay? So make sure that you do. Remember that I cannot, sometimes I don't, I may sometimes do the correction of the homework, or I might not even sometimes do it. But you have to do that homework because it's giving you something new, a new concept for you. Right? So if that's the case now, and we have been together, I would like just to thank God who have given me power to stand and teach and prepare these materials. I would like to appreciate His presence and His anointing and so forth. But I'd like also to thank you for taking your time and being patient and watching this video and learning a lot of stuff. And thank you for subscribing. Thank you for sharing with your colleagues. I would like just to appreciate what you have done. And I would like to ask you that this is the end of period of session 4. I would like to ask you join me. I would like to ask you join me in the session 5 or period 5 of gravitational mechanics, so we may break the complex issues into the simplest one, right? So thank you very much. May God bless you. See you in the next.